Yeah, good morning once again. Back here with the lesson. Before going to the lesson, the one thing I want to tell you that is about an assignments. The second assignment has been given by only 8 members. Note it down, only 8 members, and marks will be there according to that. And assignment 3 has been given by 34 members till now, which I have collected. I have not seen a mail. So maybe in a mail I saw that somebody has sent now. So even though I will take that also, almost all it will comes nearby 38 or 40 like that. What about the remaining persons? So within a span of 2 days, I will segregate. Then I don't give a remember to you to submit the assignment. Why? Because already deadlines has been completed. Those who are submitted for them, the marks will be distributed accordingly. Right. So whatever assignment marks will be there, it will be distributed accordingly. That's about an assignment. Now coming to the next thing about a mini project. Yeah, you have not submitted the poster. The maximum number of students till the date they have submitted poster, mini project poster. Yeah, is only of around, I can say like this, six are they out of 27. So another 21 posters to be submitted. Either any of you one can submit, not an issues. So that you can't submit means I can't tell anything else. So yesterday I have given a report format also. The deadline for a report, as I told you, is 30th of November. So a draft copy should be submitted within that particular time. Don't miss the deadlines. Always deadlines will be there with the marks, whatever it has been given. So don't cross the deadlines. Poster within today 4 o'clock. I am going to consolidate it all posters. And so I will finalize that particular thing. First, you send the posters today within 4 o'clock you have to submit that. Now yeah, come back to the lesson now. In a lesson in a last class we have completed the IoT reference model. In that we have discussed starting from an IoT domain and then information gathering or information view. From there the functional model we had discussed and then communication model we have discussed. So all these things we have discussed in IoT reference model in the last classes. Now coming to the next, that is the functional view. In depth, we are going to discuss about a functional view according to your syllabus. Now, what actually this functional view will explain you, and what are the functional components? Grouping all the functional components together will make a functional groups, and then from that functional groups we will plan accordingly what actually we have to do. So that is the one particular thing which we'll study in this particular topic. Now you observe this particular figure, means a diagram. This is a base diagram for this functional view. And how this I can tell like this, starting from a device, the function is there. Yes, the function components will be there, and functional groups will be there. Now coming to the next, communication layer is there, and coming to here, this is very much important in a functional way. What is that? The IoT service, what you are going to give. For that, how you are making a virtual entity, and coming to IoT process management. This we have studied in IoT reference model as just a summarized thing. Now in detail, with the elements we are going to study, means with some further components which we are going to study. This is the elaborative topic. You may feel like that, sir, already you have taught this in a functional model. We have studied one by one about the virtual entity or IoT service, maybe or a communication like that. You may feel like that. But here in depth we are going to discuss, and we are going to discuss the each and every function in a particular components. Coming to the device, for example, you can say the IoT domain model means a device wherever it will be there. The sensing, acquisitions, tags, the advice will be there, and processing and storage, where you are, how you are processing the data which has been came from either a metadata or from either a sensor. So how you are processing that, and how the storage, where you are going to store this and all. So that will play a very important role. Coming to the communication, that is end-to-end communication, either device-to-device communication, you need a network communication, hop-by-hop communication, which type and how you are going to communicate, where you are going to communicate. That is very much important. That type of functional components which we are going to say, especially coming to the service area. So this is very much important. With this particular device, and after communicating, you are storing in a cloud or somewhere you are storing of your IoT project, and what is service you want to give. Ultimately, you know that our project should help a business applications or standalone application. Sorry, something means some goal we have to achieve in an application. For that, what are the services that we have to do? First one will be an IoT service. You can see here the how an IoT service is there. Now, with the IoT service resolution is also there. So IoT service means it always thinks about on a device, how the components and how the things are there. So that particular thing. Coming to the next entity, this is another one very much important concept, virtual entity. What is this virtual entity? For example, I connected a sensor in my IoT project. I will collect a data. After collecting a data, for that sensor data, I will keep in one variable. Keeping in a one variable or one particular string variable depending on a data. I will keep after keeping the data there, and I will manipulate that particular data. After manipulating that data with that particular variables only, I will transfer that. Here, in a virtual entity, what happens? No, if I think of a sensor, yes, the sensor is, for example, sensor is like this. I can take like field one. Field one is a variable which I have fixed in Arduino, and all we'll keep on doing that. Field one. Field number one means sensor number one. So sensor number two, field number two. Like that, we are going to take as a virtual entity, and registering of that means virtual entity and IoT service monitoring, how it is going to do, and virtual entity registration is how we can declare the function. Means you want a function to be declared there in one particular program. With that function, you want to handle taking these variables into the consideration. For example, connecting to the Wi-Fi model. So you need several variables. After executing that variables, calling several inbuilt functions, it will be executed. Like that, again, the virtual entity service is what you need. Entire thing, whatever physical components is there in a environment or which the device has been connected, they will take that, and here in our area, what we'll do, we'll create a virtual entities for that. After creating a virtual entities, definitely then IoT process management, which we are doing, that is process modeling and process execution. What actually I want for my application, what are the things I should execute, means which type of data I should filter, what information I should construct, what knowledge frames I want. So this type of things plays a very much important role. Coming to the next thing, that is a service organization, that is service composition, service orchestrations, and service choreography. These are the terms which we are going to discuss. So coming to the management, here the configurator, fault reporting, member state. So these are all the management things which is needed for this particular layers. Coming to the security also, we are going to discuss this. Always we are discussing identity management, authentication, authorization, key exchange and management, trust and repository. So these are the things which is needed. Now in depth, when we go into this functional view. The functional view for an IoT reference architecture is presented in figure 8.1, which you have seen and is adopted from IoT that you know already. It consists of the functional groups. Now this is important. It consists of a functional groups presented earlier in the IoT functional model that I told you. In model we have already discussed, but these are the consists of a functional groups, each of which includes a set of functional components. Now we are going to discuss about an component. Functional groups we had discussed. Now these functional groups, each of which includes a set of functional components. Device and application functional group in that particular thing. The device and application functional groups are already covered in IoT functional model. For convenience, the device functional group contains the sensing, acquisition, tag, processing, storage, functional components, or simply the components. Now what actually this particular components will do? You know that for a sensing purpose we need a sensors. So we will use several sensors which has been connected to our device based on particular our application. So for example, my application is like that. I want to monitor the moisture level of a soil. For example, I tell you, moisture level of a soil I want to monitor. Once if I tell this particular thing, moisture sensor is must there. So I should sense the moisture level of that particular soil, means I should penetrate that particular sensor into the soil, and I should collect the data from that particular thing. So that function is must here. Then acquisition. So what is this acquisitions? Acquisitions I may need. For example, I want to run a solenoidal valve. I want to open, or I want to run one particular pump to pump on water based on a dryness of moisture level of that particular soil. Now for that, what I need actually. So that is an important thing. So to do this functional component, to execute, the motor should pump. Both are related here. Means the functional components are interrelated. That's why we'll put in that functional groups. Why? Because based on a moisture level only, I can decide whether my pump should on or not. Means my actuator should on or not. That means that both are interrelated here. For example, the acquisition, whatever is there, I'm going to use a relay model there. So how a relay model based on this particular threshold level, for example, assume if it is 550 above is there, what I will do, relay, I'll make it as 1. Otherwise, relay will be always 0. Once relay is 1 means automatically a power flow will be there in that, and in turn that has been connected to the pump. So in this way, these things will be keep on going. Tag. Different tags we may need for our projects in a different problem solvings. That is how we are going to fix a tag values. Tag here 2 types you can take here in particular terms. Tag functional component. What is this? Tagging of the particular values, what you are going to take, either from the sensing, either from acquisitions. I will tag the threshold value. If threshold value is so and so only, then automatically the means motor should on. Otherwise, for example, assume always it's a 550 below it is there, then don't switch on. So like that. So the tag, where you are tagging the milestones, means in my project, if this is the value, one tag will be there. If this is the value, another tag. For example, sprinkler should on. When sprinkler should on, now here moisture level sensor is not at all needed. Assume that pump, I can use another pump by name, and I can go with a temperature and humidity. Based on that, I want to switch on the sprinklers. So this depends on a project. Then processing. What are processing actually? In a device level, what is the processing functions I need? To finding a threshold value, either filtering a data, either aggregation of a data. These type of functions will be there always in a device level functional things or functional component. And this is one of the very important component that based on this component means this the information whatever after processing you are getting, that is very much important for our decision makings, especially after putting in a cloud and all, will make some decisions. decision based on that particular values. So storage, where you are going to store, storage functions, it depends. I will store some data until the processing, the data will be stored within a device, within a small memory there. Okay, you can store, it depends. I don't want to send all the sensor data into the cloud always. I want to send only some particular data after processing. This may depends on you that what type of data you are going to send. For example, I want to send a continuous monitoring of my sensors data to the cloud. It depends on your storage functional components and what you are going to use there. Coming to the next step. Communication functional group. The hop-by-hop communication is applicable in a case that devices are equipped with mesh radio networking technologies such as Wi-Fi, that is 802.15.4. For which messages have to traverse the mesh from node to node, hub to hub, until they reach a gateway node which forwards the message further to the internet. So here you can say like this, when hop by hop communication is needed, a large project you are going to deploy in an area that I told you, that wireless sensor networks in a broader area of the India and all. So until you are going to connect to the internet, so a sub networks will be there where hop to hop. For example, my master sensor will be there. From that master device, the communication should be done to another master device. From there, it should be done to another device until the internet connection has been established. So that we had discussed in a previous thing also. Now, coming to the next thing, that is the network functional components is responsible for message routing and forwarding and the necessary translations of various identifiers and address. Underline this. Whenever we are thinking about a network component in the communication, the network components, what for we need a networking and all. I'm having some message, means my device is having some message, assume that, and that particular message should be sent to some other place where the monitoring center is there. Why? Because the device will be in a remote place that is kept in an environment, thrown in an environment. In many cases, I can say, for example, the fire accidents monitoring in a forest. Assume that no one can stay with your device always in a forest. Am I right? So your device should be kept in a forest somewhere. A fire accident occurs, it will give you the signal and all. So signal should be given in a remote area where the forest office will be there to the guards or a forest ranger. The information should be given that in this particular location of a forest, a fire accident has been occurred. So where meanwhile within suddenly they can go and they can put off that particular fire where the fire extinguish tankers will be there nearby that forest office. Why? Because these projects, why it is needed, you can say like this, it's a social responsibility that assume the forest is of some 50 kilometers or 100 kilometers. Bandepura forest is around 150 or 200 kilometers practically. Means in a real time it is spread around Karnataka, Tamil Nadu and Kerala. Assume Karnataka area itself of Bandepura forest is around some, I can say like that, 50 to 60 kilometers. Now, 50 to 60 kilometers forest range and in depth of the forest, the fire accidents, how you can monitor, especially the project of Naina and Surya. So representing the project and your application of a project itself is one of the way to change small things in that. So once why I will tell you that in last 1 year you have seen the cause of the fire in Bandepura, how much animals has been dead, burnt in that particular fire, and how many kilometers of the forest area has been destroyed. It's not a low joke like that. Once the forest area has been destroyed, how many days it will take again a tree to grow in that particular big sense. and how much the oxygen levels will cut down, global warming, what is the situation, how many problems will arise when we go with this particular type of things. Means I want to tell you that what is the important of this project, how a functional components you have to select. That is very much important here. Coming back here, the network functional component is responsible for message routing and forwarding and necessary translations of various identifiers and addresses. So that's I told you. The translations can be A. What is that? Between network layer identifiers to the MAC and or physical network identifiers. You can say until network layer only the transformation should be done. Later on we'll take care. So what is this physical identifiers? MAC address will be there in my device level. So then B, between high level human readable host node identifiers to the network layer addresses. That is from again network layer to the application level layer. For example, my mobile app, my cloud, and so that part human readable things. So fully qualified domain names must be used there to the IP addresses as a function implemented by a domain name system server. Correct? No. Otherwise, we can't identify. Always, I can't remember my device IP addresses. So this is one very important thing. My device IP addresses at network level to MAC level and a physical layer level, I can identify. So if I cross that particular layer, means in applications and business level applications and all, if I want to identify, I need some name. So then my device should register in DNS server. So that registration process is different. When you do a practical projects and all, you will get it. And the translation between the node service identifiers and the network locators, in case the higher layers above the networking layer use node or service identifiers that are decoupled from the node address in the network. So identification of that particular device or a node, whatever is there, and how the different node means differentiating this. For that, the service identity, this node will give this service and that node will give us the particular service. So network locators in the case of the higher layers is very much important. So in this way, how my device should be identified in a public network when it comes to that this level. So what's the name I can give for that? And then the end-to-end communication, that is means functional component is responsible for end-to-end transport of the application layer messages through the diverse network and physical layers, with all taking into the consideration entire internet, what is your subnetwork, hop-to-hop network, whether your radio waves you are using or radio frequency you are using, it's left to you. And then in between that, from that layer to the internet, how you are going to connect, what method you are going to use to connect for that, based on from higher network level to the application level. So finally, the end-to-end means application level. What is that? My device or my sensors, whatever is in my device, whatever is there, from there to my mobile app, how I am going to communicate. So that is an end-to-end communication. In between, maybe a cloud is there, or maybe you are doing some other processes also. In between, maybe your own server may be there, and maybe network, many connectivity things you are using, or virtual network you are using. It's left to you. Then coming to the next thing, IoT service functional group. Now we are stepping ahead. Means the first one of that. The IoT service functional group consists of two main functional components. What is that? The IoT service functional component and the IoT service resolution functional component. Now, the IoT service functional component is a collection of service implementations which interface the related and associated services. What is the related and so for a sensor type of a service, the IoT service functional component includes services that receive requests from a user and returns the sensor resource value in synchronous or asynchronous way of a fashion. Now, what actually the IoT service functional component, if I want to tell you that, how you are going to relate and associate resources with a human or with a user. For example, I am a user of your project, and how you are going to associate your device, maybe your gateway, whatever the components if you are using, how you are going to relate that, associate that resources to me, and how the maximum returns you are taking from that particular resources. The IoT service resolution component, functional component, contains the necessary functions to release a directory of IoT services that allows a dynamic management of the IoT service descriptions and discovery, lookup, resolution of IoT services by the other active digital artifacts. So what actually this resolution component is there? So this resolution component is that what are the IoT services is going on, logging on that, registering that, means the directory of the IoT services will be opened and it will be keep on taking that. Say that your IoT service is not doing correctly, dynamic management should be there on that. What is that? We should discover that where is a fault is going on. We should discover, we will look up always that either the values is coming in our range only. For example, every 15 minutes I will check up my device that what type of a value it's going to give. And like that, every 10 minutes I will check it out that what type of a value it's going to give. Why? Because our device is thrown to environmental always. Any damage can happen. Many environmental constraints will be there where it can be damaged. Our sensors even it can be damaged. So for that, the directory of that means logging of that, discovering of that, looking up resolution of IoT services by other active digital artifacts means we will keep on observing that whether the service is giving correctly or not. The service descriptions of the IoT service contain number of attributes as seen earlier in the IoT functional model selection. Coming to the next, virtual entity functional group. So the virtual entity functional group contains the functions that support the interactions between the users and the physical things through virtual entity services. Now, what actually this? This particular group contains the functions that support the interaction between users and the physical things. I'm a user and a physical thing. I don't know how the, for example, I'll tell you, moisture level sensor. It will be always it's of like V shape and it will be penetrated into the soil. That I know as a user, I know that how it is working, how it is giving a value and all. Assume that in a signal method it will give wave format and all. I can't read as a user. So what I should do means for me, my device, what it has to do, it should convert that the whatever level of moisture is there, whatever signal is there, it should convert to a particular value. And after converting that value, I will store that value somewhere in temporary variables, and then user can read it very easily. So then the user can decide on what the value the moisture is there or not. An example of such an interaction is the query to an IoT system of the forum. What is the temperature in the conference room? Titan. Now, if I want to know the temperature in this particular room, so what is the temperature? The virtual entity is the conference or this particular room where I'm teaching you. And the conference room attribute is of interest is temperature. Now temperature will become automatically the variable. Now this is entity in this particular room. What is the temperature? Now you can see this is the experiment which it is there here, and the DHT it will show that. Now in this particular room, what is the temperature and humidity is there. Now it is ready with me, the node MCU, and I can connect this. Once if I connect this particular device here already burnt, so now once if I connect to this particular device, I'm having a port in my thing speaker, then automatically I can see what is the present thing here, means temperature and humidity is there in this particular row. So automatically, when you see my particular code, how I have written and all, You can see there for a room especially, means the particular place and all. I may give one particular entity name or a class name like that, and temperature, I will take always into field one, temperature, something like that. I'm going to read. So in this way, we are evaluating this particular experiments. For that, the virtual components is needed. Next, the virtual entity service functional component enables the interaction between users and virtual entities. Sorry, by means of reading and writing the virtual entity attributes. 100%. It's very clear. For example, if I want to know, I'll tell you like this. I'll keep one particular picture there, assume, and camera, Gaurish project in a forest I'll keep. I want to monitor whenever a tiger comes, I want to monitor. Means I want to record the movement of that particular tiger just for a second. I don't know any other animals what it will come. Now I placed the camera there and I came back. How I can identify a tiger? Only a tiger. How I can identify? So what I will do, if any one motion is occurred, so once a motion is occurred, I will capture that particular component, and that means the entity, and I will compare with already my entity what I have written. That means what are the characteristics of the tiger. So that is very much important. That's why it's a golden color skin with black stripes. It should be there. Black stripes should be there even for a zebra also. So golden color skin it should have like that, and it should be in a cat family. Some features you can also identify. I can identify only these many features. Like that, if this type of problems will come, means height of the maybe tiger will be always with this particular height, maybe this particular long. Even you can take all that characteristics. Once the capture has been done of that particular picture, that picture entity, I will be compared with this entity, and then we'll identify, yes, this is a tiger. Once it is a tiger, then I will tell my camera, keep on recording now. Why? Because assume that for 10-20 days, tiger will not come. I will keep a camera and I will go out. How many means my data will be keep on recording, means camera will be, if this experiment is not there, just for a second I'll tell you, the camera will be keep on recording. So how much data it will keep on recording simply, and how much storage area it will eat up. Again I should delete all that data. Again I should put that data. So this type of things means when you come, the virtual attributes will play a very much important role. So you can see the virtual entity attributes, how simple or complex you can use. It depends on your project, which can be read or written, of course. Some attributes, example, the GPS coordinates of a room. So that is very much important. Means I can say how I can locate a particular location or in a building. Just I need a longitude and a latitude of that. So how I can get a longitude and a latitude of that particular place. That is very much important. Then I will use a GPS. So once I will use a GPS, so entire Earth I will cut into the longitudes and the latitudes. So automatically at what particular coordinators of a longitude and a latitude it will be there. I will give some X and Y values and I will catch that to the X and Y values, longitude and latitude, and at that particular coordinator again I will have a map with me. So I will compare that with my particular map. Then automatically I will get at that particular point the coordinating, this is a so and so place is there, or this is so and so of your building is there, like that. So here also I need some virtual entities, and a non-writable by nature and some other attributes are non-writable by access control rules. It depends. So either you can write it or either just you want to read it or it depends. The virtual entity registry functional components. What is the mean of registry? Means what do you mean by registry? Maintains the virtual entities of interest for the specific IoT system and their associations. That is why I need these variables. How these variables are interrelated with each other. How are it's dependent with each other. So if I vary one particular variable there, what is the effect of that with all the other variables, including my application or a final output? The component offers the services such as creating in a virtual entities, reading, updating, deleting virtual entity descriptions and associations. Coming to the next, the virtual entity resolution functional component. What do you mean by that? That maintains the associations between the virtual entities and the IoT services. This is very much important. What actually your field is doing and how your virtual entities is related to that. So with this virtual entities, why? Because after your virtual entities, the application is there. That means your virtual entity is so important that whatever it's connected to this IoT service, internal IoT service is connected to the IoT device there. So whatever the service is going on, whatever information is coming out, either you are taking that correctly and offers the services such as creating, reading, updating, deleting associations, as well as lookup and discovery of the associations with that particular groups. The virtual entity and IoT service monitoring field components includes what it includes. Functionality to assert the static virtual entity IoT service associations. That is functionality to assert the static virtual entity IoT service associations. What I want to specify one particular virtuality entity, static always, and it will be related to the IoT server. For example, every 15 minutes I want to monitor, or every 10 minutes I want to monitor the temperature or carbon monoxide level in that particular area. Maybe functionality to discover new associations based on existing associations or virtual entity attributes such as location or a proximity. Means how I can take out a new variables or means new entities, how I can make with the existing variables with that particular data. Presently, I want a location in that particular moment, or I want a proximity. Proximity, what I can say like this: what is the mean of the moisture level which is there from morning to night in that particular area. Like when I think on this particular type of things and all, definitely what I need every 10 minutes or every 15 minutes, what I have taken a moisture levels, I will take all that, summating all that divided by how many values it's there, how to find a mean. Perfectly, I need the standard deviation I want to make. Depends. It depends. For this and all, again, you can build a new virtual entities for that with the old one. Continuous monitoring of the dynamic associations between the virtual entities and IoT services and updates of their status in case existing associations are not valid anymore. Maybe it depends on that. Always I will think on a dynamic associations. Why? Because once I will fix an association between a virtual entity and that physical device, maybe my physical sensor devices will change depending on environmental factors. Depending on different situations, I want to change that association. That is another one important thing which is needed here in monitoring. Then IoT process management functional group. The IoT process management functional group aims at supporting the integration of business process with IoT related services. My business application is this, either your IoT project is capable to monitor that. Now, what are the functional components in that? The process modeling functional component provides that the right tools for modeling a business process that utilizes IoT related services. This is a damn important thing and important step here. Assume I'm having a 3 months or 1 month of any data is there in my particular cloud, which I have extracted after gathering, after filtering, after monitoring, after taking a threshold values, everything I have did, evaluated, all the process I have did in a previously like that, and have stored now a pure data information in a cloud of 1 month or 2 months that data is there. Based on this, how I can relate this to a business. So this is a very much important thing. What I can say like this. So based on this, how a different business links we can establish. As I told you that air pollution monitoring, the hospital business, how they can view on that particular way of entire model. Means if the carbon monoxide or carbon dioxide footprints is more in that particular area from last 3 months it is there, in another span of 3 months it will become still more, then the allergic hospitals will be open in that particular area. Why can't we do the business and all? That we have discussed in the beginning chapter only. We have discussed in the trust management, how a trust management will be there. Assume the trust management patient is monitoring remotely with an IoT, and we'll finalize that why he is having a trust in which place, either in a working place, either in a home, what type of stress is having, what is the effects of that regarding a BP or a sugar like that. Finally, from expert knowledge means the doctor knowledge, whatever we have kept a metadata from that. What is the suggestions? That is weekend. You go to any green places. Living all the stress levels and all, relax yourself. Assume this is a treatment suggestion which has been given by a doctor, then automatically you should go for that. And if this data is available in a cloud, it is very useful data for the resort persons who are there in a valleys and all. Definitely for them, it's a business process. So what they will do, how many these type of patients are there? So they will take all their details, data and all, phone numbers and all. They will give a message, ours is so-and-so resort in a valley place, which is of greenery, so-and-so, and which is with so-and-so comforts. And their advertisements they will do. Definitely out of some 100 or 200 members, just a small example I'm telling you, assume some 10 to 20 members are coming, how much business rotation will be there? So these things are very much important. And the process execution functional component contains the execution environment of the process model created by the process modeling functional component. That is, what is that? The execution environment. I see traffic police will view my air pollution in different way, and hospital fellows they want in a different way. Pollution board fellows they want in a different way. They will view in a different way. That is called as a process execution. That is the process execution environment of the process models created by the process modeling. For them, I will do this. I will take out this type of data. For the traffic police, I will take out this type of data. Executes the created process by utilizing the service organization, the functional group, in order to resolve high-level application requirements to a specific IoT services. Next, the service organization functional group. The service organizational functional group, the service acts as a coordinator between the different services offered by the system. What is what is this? Whatever the services your project is giving, entire project, it will be in a hub. It will connect all the things. It consists of the following functional components. The service composition functional component manages the descriptions and execution environment of the complex services consisting of similar dependent services. Small services, whatever it will take and it will solve the complex service. So that is called as a service composition. An example of a complex composite service, sorry, is a service offering the average of the values coming from a number of simple sensor services. Maybe like that, different sensors, whatever is there, I will take the values. For example, air pollution monitoring, entire city I want to do, I have kept in a different areas, and each node is only different, that each sensor should be identified. How this, then our simpler dependent services will be taken, and it will be taken in a Bangalore. In this area, assume for one area, 4 to 5 devices you are kept. In this particular area, what is the air pollution? You have to tell finally. Then the service orchestration functional component resolves the request coming from the IoT process execution functional component or user into the concrete IoT services that fulfill the requirements. Next, the service organization functional group. The service choreography, that is the functional component, is a broker for facilitating the communication among the services using the publish or subscribe patterns. Users and services interested in specific IoT related services subscribe to the choreography functional component, providing the desirable service attributes even if the desired service do not exist. I need this type of a service only from this IoT. Assume that there are n number of vendors will be there, or business processors will be there, and we are having one cloud data there. So for this n number of business persons, one business person is a different person and another person is a different, and he needs our data with so and so things. How means one third party will be there, he will become a broker for that, and he will tell publish and subscribe the pattern. What pattern of a data he need, only that things will be published to this particular vendor. So that is called as a choreography, means that taking the things way how they want and presenting to them. So that is a thing which you can do here. Then security functional group. The security functional group contains the necessary functions for ensuring the security and privacy of an IoT system. It consists of following functional components. What are the following functional components? The identity management functional component manages the different identities of the involved services or users in an IoT system in order to achieve anonymity by the use of the multiple pseudonyms. So yes, 100%. Why? Because always our project will be there in a public environment and we are connecting to the internet even. So who are the users of us? We need to identify them. This identification itself is a big process, and for this particular identifier I should give only this service, and for this identifier I should give another service. So how these services will also be identified based on a users. Then the authentication functional component verifies the identity of a user and creates an assertion upon successful verification. It also verifies the validity of a given assertions. So means authentication, username, password will be taken, verified that. Authorization. What is this authorization? What are the policies, control policies, what he can access, what he can take, how much he can take, what are the policies he should follow when you want to take a data from our IoT based project. So that things will be there as an authorization. Next, security functional group means going with that. The key exchange and management is used for setting up the necessary security keys between two communicating entities in IoT system. This is damn important. Why? Because you may communicating from device to device. You may communicate where human interactions will not be there and devices are very far place. So this is what type of a key exchange management you are going to use there, and how these things you are exchanging between them, means which type of a cryptography algorithm you are adapting there, but no one can hack that particular thing. So that's the trust and reputation functional component manages the reputation scores of the different interacting entities in an IoT system and calculates the service trust levels. So remaining thing we'll discuss in a coming class. I'll stop here. Yes, I'm back. Any doubts is there? You can ask me now. Any doubts is there? Any doubts? ಓಯ್ ಎಲ್ಲರೂ ನಿದ್ದೆ ಮಾಡ್ತಿದ್ದೀರಾ? ಎನಿ ಡೌಟ್ಸ್? ಇವಾಗ ಅರ್ಥ ಆಗಲ್ಲ ನಿಮ್ಗೆ. ವೆನ್ ಯು ಗೋ ಟು ದ ಕಂಪನಿನಲ್ಲಿ ಇಂಥ ಪ್ರಾಜೆಕ್ಟ್ಸ್ ಇದ್ದಾಗ ನೆಕ್ಸ್ಟ್ ಎಲ್ಲ ಬರೀ ಇಂಥವೇ ಇರ್ತವೆ, ಅವಾಗ ನಿಮ್ಗೆ ಇದ್ರ ಬಾಧೆ ಗೊತ್ತಾಗುತ್ತೆ. ಅಯ್ಯೋ ಸರ್ ಹೇಳ್ದಾಗ ಕೇಳಲಿಲ್ವೇ.